Hi, in this video we are going to talk about the architecture of DroneEngage that implemented by Aerial Metric, because this implementation is not the default implementation. So let's see a new way to implement DroneEngage. Let's start. This is the original set. We have here a VTOL, and on the VTOL itself there is a Raspberry Pi board that runs DroneEngage Mavlink and DroneEngage Communicator. The first module communicates with the flight control board on the VTOL. That could be anything. It could be a orange cube, for example, and it forwards the traffic to drone communicator that is connected to a 4G module that communicates with the air gap server, which is the DroneEngage module, cloud module, which can run completely isolated from internet in our case, and in other cases it can be deployed on for example a normal server or AWS server or any server that is exposed to internet based on the keys. And using a web client we can monitor and control the drones. In aerial metric solution, each drone has a flight control board attached with a Raspberry Pi that runs a proprietary software, and this software receives the Mavlink messages from the flight controller and sends it to a ground station using different technologies, including 4G or satellite. And so we don't have here a DroneEngage mounted on the vehicle. Actually, we have DroneEngage here on the ground. This is a different configurations. It's very interesting, by the way, because you are receiving here different Mavlink messages from different drones using different system IDs, and as a ground station forwards these messages to a drone adapter, DroneEngage adapter. DroneEngage adapter is a new module that is developed. It's actually a modified Android web plugin. It is a message, it is a Node application, Node.js application that receives Mavlink messages with different IDs, and then for each ID it communicates to a different drone module. So the drone module here receives message from the flight controller. Here the drone module receives message from a flight controller. For example, this DroneEngage module receives Mavlink with sysID 1. This drone module receives Mavlink messages with sysID 2. This module receives Mavlink messages with sysID 3, and etc. Then it is connected to air gap server that is connected to the web client. Using this solution, we can monitor the movement of different drones on the website, and by exposing this server, actually in our case we expose only the web client port, so you can view this web client and monitor the drones from any place on the earth if you want. There is a variable here that is called read only, and this variable, if it is true in the config file of drone Mavlink, if it is true, it disables the user from controlling the drone. So in this project we want the user for time being to be able to monitor the drone and not controlling it. So it is a read-only view, and the traffic here is secured and isolated because this server is not accessible from internet except from port 443, which is the SSL connection to allow web client, and it can be closed, and it can work only internally in the office. So it is not exposed to internet. The new challenge in this solution is how to run DroneEngage on Earth, not on the plane, and still each module is connected to a certain plane and without modifying the code so that aerial metric can update their DroneEngage versions without the need to special modification. So actually this is the public solution, and this is the new configuration of the public solution and new possible way to using DroneEngage. Now I will leave you with a fast forward of the completion of the mission that we saw in the previous video. Thank you.